Now that we've added this explosion to the shot, let's go ahead and add some fire to this. So to do our fire setup, I'm, as usual, just going to go back to the object context here, and I've created a geometry object to do our fire setup in it. And let's dive inside there. And let's merge in the creature. So drop in an object merge, point that to object / creature ground, and out creature jolt. And this creature, as we've seen before, is animated, and I'm just going to start setting this on fire in the position that it rests in. So I'd rather not have animated input that forces our sourcing and collider to cook on every frame. So let's just freeze this in the end position that will actually be burning. So drop in a time shift, and on the time shift, Control-Shift-Click on the frame to get rid of that expression there. And our animation ends around frame 90 or 95. So as long as we time shift this to any frame later than that, it'll be fine. So I'll just do any frame later, like 150, and display that time shift. So we have this creature just sitting at its end position. So let's chop off the section that we want to set on fire. So let's do a selection. So go to our selection tool, select primitives, turn on selection by groups or connected geometry. We'll select based on the path attribute and select this mouth geometry here. So I'll hit delete and then flip that to delete non-selected. I'll call this blast isolate mouth. Then I'll create a grid. And let's grab this grid and turn on point snapping so we can move this into the position that the creature's in. So turning on point snapping here, let's grab that grid, move this into place and snap it to the creature here. And when that's in place there, we can finesse this position to cut off just the region that we want to set on fire. And to make this a little bit more easy to position correctly, I'll display the grid and template display the creature. And I'll turn off point snapping to fine tune this without this snapping around randomly. So now that we have this grid positioned, let's make sure this is big enough to cover the entire space of the creature there. Something like that should be fine. And then we can do a Boolean with this grid. So I'll drop in a Boolean SOP, connect the creature to the first input and the grid into the second. And then on this Boolean SOP, let's display that, and we'll set the operation to intersect and turn off the template view for the rest of the creature. It's picking the wrong side of that plane there, so let's flip this to subtract instead. So this is just giving us the mouth of the creature that we're interested in setting on fire. And then we can scatter some points on this to create a pyro source from that. So drop in the pyro source SOP, and we'll do a surface scatter. So set the mode to surface and display that pyro source. And this is a somewhat low resolution point cloud here. I want these points to be rather dense for this source here so that we can get a lot of detail and the noise that we're about to add. So I'll turn this particle separation way down to 0.02. So this is giving us a very dense point cloud. It's about 500,000 points, and this will work nicely for us to create a nicely detailed noise on here that we can source from. And we're going to create a burn volume to source some flames into the simulation. So let's create a burn attribute on these points that we'll create the volume from. And we ultimately want this to be kind of a cellular shape to this noise, because if you look at some real world references for the way that flames form off of surfaces, it kind of creates some vaguely cellular patterns. So let's drop in an attribute noise. And I'll start by leaving this called CD for color. And if we display that, you can see this is an actual RGB vector color, but we want this to just be a single scalar float value. So we can set this to float to make it just a black and white color instead. And we can turn on some animation for this. Turn on that animate noise here. And I'm going to leave the default speed on this. You can, of course, do a flipbook if you want to play around with the speed of this noise evolving over the surface. But I actually found the default speed of this noise worked reasonably well. And let's take a look at some of the different noise types to find a noise that looks a bit more cellular than this. The simplex just kind of looks like a cloudy noise to me, and this might look fine if we build our burn source from this, but let's see if we can find something that works a little bit better. So if you look at the bottom here, we have these whorly cellular noises, so those are going to likely be somewhat promising. This whorly cellular Chebyshev, or however it's pronounced, is looking pretty good. That's one decent option. And scrolling through all of these noises, they all look pretty cool. But the one that I settled on for my burn source is this whorly cellular F2-F1. I thought these shapes looked pretty cool, and I'll just boost the scale of this a bit. So this should give us some pretty interesting burn shapes here. However, this noise doesn't look like it's going dark enough, and part of the reason for that is that this default behavior of the attribute noise is set to add, and we have some existing color values on this incoming creature mesh here. So you can see that this already has some color applied to it, so whatever we're applying and the noise is just being added on top of that. So instead of doing an add, let's flip this to set. So now you can see we're getting a much nicer pattern with a better range all the way down to black. And I'll do a flipbook of this to see what the noise looks like when it's animated. The flipbook of this animation looks quite cool, but this is still going to give us some emission everywhere, all over the surface, all the time. The burn emission is going to be a bit broken up by this noise, and this should yield some nice and interesting sourcing, but we want some larger splotches that are blacking out this emission at times, and those large splotches will shift over the surface as well. So back in our setup, let's add another attribute noise and wire this after the previous one, and the second one will set the operation to multiply. Make sure that this is also a float color as well, not a vector. And for the range, I'm going to set this to a minimum and max that goes from 0 to 1. And let's take a look at what that looks like here. This is going to be some pretty small detail noise that's added in, so we're not really getting big splotches here yet. So let's crank up that element size. I'll try turning that up to 7. And for the fractal, let's turn this off. I'll set the max octaves to 0. And you can see this is affecting our previous noise, but just to get a better sense of what this individual layer looks like, let's go up to the operation and flip this back to set for the moment so we can just see this one layer of noise here. So you can see we are getting some kind of large patches that are being multiplied down here by these darkened colors, but it doesn't really go very dark. This could go down all the way to pure black to really block out the emission in those areas. So let's turn on this enable remap ramp option here. And then on this ramp, we can add a bit of a fall off here so that we get a large section of this color range that's going to be set to pure black. So setting the first point on this ramp to around 0.3 looks pretty good to me. And then we can set the second point and bring that down as well. Maybe I'll set that one to about 0.4. So this gives us some very distinct areas where the emission's going to be masked out entirely. And right now, this noise isn't changing at all because we haven't set this one to be animated. So let's go down to the animation setting on this one, enable animation on this as well. So now we have these large patches of noise that will cause just a little bit more breakup in our burn emission. And of course you can play around with the ramp if you'd like some larger areas of this noise to be blocked out from that emission. But I think this is good enough for now, just so that we get some amount of additional breakup here. So if we go to one of these frames where there's a particularly large blackened area, and we can use that for comparison as we go back up to the operation on this noise and flip this back to multiply. So now you can see we still have this nice cellular pattern on most of the mesh with just some random areas getting blacked out here. So now we can go ahead and create a burn volume from this, and I'll start by renaming the color to burn. So drop in an attribute rename, connect that to our noises, set the attribute from to CD, and the new attribute name will be burn. And if you display that, you'll see we can't really see that color feedback anymore. And you can add some custom visualizers in your viewport so that you can see some visual feedback for some other attributes besides color, and you can add those by right-clicking on this icon here, but I don't usually mess with those very often. In any case, we have our color converted into a burn attribute, and now we can rasterize that into a volume. So drop in a volume rasterize attributes, and in the drop-down, we'll select burn, and then display that. And for the voxel size on this source burn volume, I often like to channel reference this to the Pyro solver. So we can drop that solver in, connect our burn volume to this Pyro solver, and for now I'll just leave the default voxel size on the solver here, and we can copy that parameter, and then paste a relative reference into the voxel size on the volume rasterize attributes. And this is an optional step, but it can be helpful to make sure that the resolution of your source matches the resolution of the simulation. It's not a rule that that's the case, but in many cases I do like to do that. And now let's also create a collision volume to wire into the second input of that Pyro solver. So for that, let's just isolate the creature's body. So I'll drop in a null, connect the creature to that, and to select the creature's entire body here, I'm going to bring up my selection tool, make sure it's set to primitives, turn on selection based on groups, and we'll once again do an alembic paths selection, and we can pick any piece of the body here, because once I select a piece of the body and hit delete, and then flip this blast to delete non-selected, then we can tweak the path in this blast stop to isolate the entire body region. So I've set up the path attributes on this creature so that all of the different sections of the body are prefixed with creature/body, and then the various parts of that fall after creature/body here. So we selected creature body main, but if we change this to creature body/star, then this will isolate all of the pieces of the creature that have a path attribute prefixed with creature/body. So this helps us to isolate this entire region. And with this region isolated, let's create a collision volume for that. So I'll drop in a VDB from polygons. We'll set the name of this to be called collision, because if you remember from some of our previous volumetric sims, this Pyro solver's second input here can look for volumes named collision if you set this collision setting create from to SDF plus volume velocity. So this will use any volumes named collision for the collisions in the sim. So it's very important to get this name right. And just to keep things nicely organized and labeled, I always drop nulls after my colliders to label them as such. I'll call this vol collide, and then wire this into the second input of our PyroSim. And as we did with our burn source volume, we can also copy the resolution of the PyroSim here, copy that voxel size, and I'll paste that relative reference into our collision resolution as well. On that VDB from polygons, I'll paste the relative reference in there. So now we have this SDF collision volume for the creature, and we have our animated burn source over here, which I suppose I should also label as well. Drop in a new null, call this source burn. And now with all of these source volumes set up, we can go ahead and start working on the simulation.